to look at is an indicator. What is an indicator, my dear student? An indicator is a compound that changes color depending on the chemical environment. Either pH or presence of ion. They change temperature. They change color depending on the presence of the pH presence and the presence of ion. Generally, know that indicator changes what? Color. So that is the most important thing you should know. Types of indicators. We have acid-base indicators. Weak organic acid or base, which this one a big thing for you to understand. Just know we have acid-base indicator. The most common acid-base indicator is what? Litmus paper, of which I think I did something about it in front. Litmus paper. Litmus paper, we have the blue litmus paper, and then we have the red litmus paper. Now, blue litmus paper, when you dissolve it in acid, it changes from blue to red. The red litmus paper, when you put it in base, it changes from what? Red to blue. If you put blue litmus paper in base, it will remain blue. If you put red litmus paper in acid, it will remain red. If you put blue litmus paper in acid, it will change to red. If you put red litmus paper in base, it will change to blue. But if you put blue litmus paper in base, it will remain blue. Put red litmus paper in acid, it will remain red. This is a common type of indicator we have. Others are phenolphthalein. Phenolphthalein is usually acidic and it is used for pH less than 8.3. Are you getting it now? For weak acid and a strong base. That is what phenolphthalein is used for. For weak acid, just note, weak acid and a strong base. That's what phenolphthalein is used for. All right? Now, methyl orange. It is used, and if phenolphthalein is colorless in acidic medium and pink in basic medium. Please take note. Phenolphthalein is colorless in acidic medium and pink in basic medium. Take note of this. What's the color change? If you put phenolphthalein in any acid, they may give you a particular acid like ACl. Put phenolphthalein in ACl, what would the color change from colorless to, or let's say, phenolphthalein is colorless in an acidic medium, but when it now changes to a basic medium, it becomes what? Pink. Used for strong base and weak acid titration. Then methyl orange used for strong acid and weak base titration. You can see strong acid and weak base. Then when you have a strong acid, strong base, you can use any indicator, universal indicator for that one, strong acid, strong base. But strong acid, weak base, methyl orange, which is red in acidic medium and yellow in basic medium. Please take note of this. It's very, very important. The color changes in various medium. Very, very important. Now, redox indicators. Now, it changes color upon being oxidized or reduced. When something is being oxidized or reduced, it changes color. I've told you that in redox indicator, most times, when you use a KMNO4 is a self-indicator. It does not need any indicator. But if it is potassium, this thing as the oxidizing agent, potassium heptazodichromate, you will be needing what? Diphenylaniline. All right? Diphenylaniline. Diphenylamine, rather. Something like this. Diphenylamine. Is that okay? It's reduced form, violent, colorless in the reduced form, and violent in the oxidized form. Now, specific ion indicator. Form a color complex with specific ion. For instance, you know that starch forms a deep blue complex with iodine. This is what is used in iodometric titration. Starch forms a deep blue complex with iodine. Please take note. Starch, these are ions. In the presence of an iodine, starch forms a deep blue complex. And this is one of the tests that is used to check for iodine, starch, carbohydrate, test for carbohydrate. Starch with iodine forms a deep blue complex. Then potassium permanganate for precipitation, titration, or chloride determination. We also talked about it, that we use potassium permanganate, potassium chromate for precipitation titration. Look at it. We discussed something like that. Precipitation. say we use potassium chromate rather, it gives a red brick red precipitate. All right. So all these things, they are just what they are trying to tell you, that they are used to know whether the reaction don't happen or it never happened. Just note them and the various reactions that you use, various indicator. That is the most important thing you should know. All right. Now, self-indicator, talked about it severally. The titrant itself has an intense color that signals endpoint, KMNO4, which becomes colorless when reduced to manganese 2+. You know this KMNO4, if you want to calculate the oxidation state of manganese here, calculate the oxidation state of manganese here to be what? Potassium is +1, manganese is what you are looking for, then oxygen is -2 times 4, which is 8. Everything should give us what? 0. This is how to calculate oxidation state right from secondary school now. Oxidation state of all these things should be equals to 0 because a neutral molecule. So there becomes +1 plus what? Mn -2 times 4 will give us -8 is equals to 0. So at the end of the day, our Mn will be 8 crosses to this side, gives us what? 8 minus 1. So manganese is +7. So a situation where the oxidation state of manganese is changing from +7 to +2, you know that, oh, manganese has been reduced because the oxidation state reduced from 7 to what? +2. Is that okay? Now the first permanent pale pink is not like colorless. Are you getting it? It forms a pale pink color, very pale, like it decolorizes the potassium permanganate to something pinkish, not like white. Are you getting it? Indicates the what? The end point. Is that okay? So when that is what happens in that particular, but the most important thing you should know is that potassium permanganate is a self-indicator and it is used in which experiment? In Redox titration. And what is the color? The color is deep purple. Please take note of it. Deep purple color. Now, the primary purpose of titration is to, let's just answer some few questions, is to determine the concentration of an unknown solution. That is the primary purpose. That is why you are carrying out titration, to determine the concentration of what? An unknown solution. What is the key characteristics of a good primary standard? It must be highly pure and stable. Any standard you are using should be highly pure because that is why you are using it to compare somebody. Person when they say hand stain, they're not using it to compare other people. All right? It must be highly pure and stable. Now, in titration, to find the concentration of HCl using standardized sodium hydroxide, what is the role of sodium hydroxide? No, standardized sodium hydroxide means sodium hydroxide is the titrant because it's the one that is standardized. You want to find concentration of HCl. HCl, which concentration you are looking for is the what? Analyte. While sodium hydroxide is the what? Is the titrant. The theoretical point, theoretical emphasis, where the mole of acid equals to the mole of base is called what? The equivalent point. The theoretical. Why if it is experimental, where there's color change, you call that the what? The end point. But theoretical is the equivalence point. Potassium hydrogen phthalate is commonly used to standardize solution of, this one is commonly used to standardize sodium hydroxide. Potassium hydrogen phthalate is a primary standard. Every primary standard is a standard whose concentration is accurately known. It is pure, it is stable, and that is what is used to actually standardize titrants like sodium hydroxide and so on. So potassium hydrogen phthalate is commonly used to standardize solution of that. Now, which indicator is most suitable for titration of a strong acid with a weak base? Strong acid, weak base. Which of them did we say? Strong acid, you can come back and check, or you should have put it in your head by now. Strong acid, weak base, methyl orange. Strong acid, weak base, you use methyl orange. Strong base, weak acid, phenolphthalein. In a Redox titration using KMNO4 to titrate iron or ferrous ion, this is ferrous ion. You may see it as ferrous. they may just say ferrous ion. Are you getting it? While Fe3 plus is the oxidized form, which we call ferric ion. The chemenophore acts as the what? Chemenophore. What is the role of the chemenophore? Is it complexometry? No, this redox titration is not complexing agent. It acts as the self-indicator. Are you getting it? Chemenophore is the self-indicator. Ion is what you are looking for. Ion is the analyte. Are you getting it? You are using chemenophore to titrate ion. Chemenophore is the titrant, which we say it also doubles as a self-indicator, while the ion is the what? The analyte. Is that okay? So that is that for that particular one. Let's see. Okay, we'll have a question here. If 25 ml of an unknown concentration of ACl requires 22.5 ml of this to reach the endpoint, what is the concentration of ACl? The ratio is ACl plus Z equals to the ratio is, from what we can see here, the ratio is 1:1. So it means Na is 1, Nb is 1. Is that okay? Coming. So let's now solve. 25 ml of an unknown concentration of HCl. It means the volume of acid, because they say unknown concentration of HCl is 25.0 ml. All right? Concentration of the acid is unknown. Requires 22.5 ml of the volume of base, 22.5 ml. Concentration of base is 0.100 molar. To reach the endpoint, what is the concentration of ACl? We have CaVa all over CbVb is equal to what? Na over Nb, my dear student. Is that okay? What is our Ca? Is unknown. So we say Ca. Va is what? 25. Cb 0.1. Vb 22.5 is equals to what? 1:1 or 1/1. So at the end of the day, what are you going to have? 25 times Ca will give us 25 Ca is equals to 0.1 times 22.5. So taking it up here, Ca will be equals to what? 0.1 times 22.5 will give us what? 2.25 divided by 25. So Ca will be equals to 2.25 divided by 25. What will that give to us? So we'll have 2.25 divided by 25. Oh, that big. That will give us 0.09. All right, 0.09 molar. So the correct answer is 0.09 molar, which is option A. 0.09 molar. It's a very simple something, right? Exactly. So the sharp change in pH near the equivalent point of an acid-base titration is called. Now, near the equivalent point, there is a sharp change in pH. It's called pH jump. Are you getting it? It's called pH jump. Now, Eriacone black tea is an indicator used in which type of titration? Told you Eriacone black tea has to do with what? Complexometric titration. So that is basically that for that. Okay, see the Mumu redox titration here. Under types of titration, I actually discussed it earlier, but let's just go through it again. Redox titration, oxidation reduction, we said it involves the transfer of electron between what? Reactant. Example, Determining the concentration of hydrogen peroxide, the titrant used is standard potassium permanganate. This, it could also be concentration of what? Iron. Hydrogen peroxide acidified with this self-indicator potassium permanganate. The first pale permanent is the end point. Changes from purple to pale pink. So basically, we looked at this before. Now, litmus paper, talked about it. Blue litmus paper, if it remains blue, it means that the something is what? Basic. If blue litmus paper remain blue, if you put an inside solution, it remain blue, it means that that thing is basic. If you put litmus paper inside solution, it can't turn red, it means that that thing is what? Acidic. I've said before. If red litmus paper remain red, it means that that thing is what? Acidic. Why if red litmus paper turn blue, it means that that thing is what? Basic. Is that okay? So we basically looked at all that. I believe that is that for that particular one. We'll see in the next one. The next one, we are going to look at laboratory equipment, right? Laboratory equipment we use in the lab. The lab, right? What are some laboratory equipment we use for acid-base titration? The setup for a titration requires precision glassware to measure volumes accurately and other equipment to facilitate reaction. What are these precision glasswares we are talking about? Talking about burette, talking about pipette. Are you getting it? We are talking about volumetric flask. These are precision glasswares. The major glasswares, these are the critical pieces used to handle and measure liquid. Burette, that thing when we say now you dey open, some as you can't jump enter the other this thing under. Like there's so this is setup. You know, titration setup is usually like this. The one that has a knob here where you open, and then the titrant is usually here on the burette. Are you getting it? And then into the analyte. That is what we call the burette. And that is what gives us the burette reading. Are you getting it? Now, what is the burette? To dispense the titrant in a controlled, measurable manner. It is the primary source of the solution of known concentration. The solution of known concentration is usually on the burette. Precision burettes are typically marked in 0.1 milliliter increment. Key feature: the precision of burette allows for the accurate determination of the titrant volume used, which is the central measurement in the calculation. Are you getting it? Now that burette, now they tell you the burette reading, and that burette reading is what you usually use to do your CAVA and so on and so forth. Now, tips, useful tips. Always read the meniscus at eye level to avoid parallax error. Always read the meniscus at what level, my dear students? Eye level, to avoid parallax error. Now, also remember to subtract the initial reading from the final reading to get the volume used. Initial burette reading, final burette reading. Subtract them to get the volume of maybe acid or volume of base used. Is that understood? If your initial is already 0, it means the final is also equal to the volume used, because anything subtract 0 will still give us that same thing. So that is that for burette. It's something that everybody knows. Then pipette. Pipette is used to transfer a fixed. Burette is used to transfer variable. Like you can put 5 mil, 10 mil, 15 mil using a burette. Once you open it, it drops. You close it back. But for pipette, it's only one calibration it has. A 10 mil pipette cannot deliver 5 mil. Let us say this is a pipette, something like this. If this place is marked 10 mil, if this pipette is 10 mil, it means once the volume gets to this place is 10 mil. So it is used to deliver a fixed, precise amount of the analyte. Analyte, the solution of unknown concentration to the titration flask. So it is the burette, the pipette that is used to what? Deliver analyte into your conical flask. Why burette is used to deliver the titrant, pipette is used to deliver the analyte. Are you getting it? All right. A long description. What is the description? A long, narrow glass tube with a large bulb in the middle. Something like this. Long, narrow with a large bulb. This is the bulb we are talking about. In the middle, and a single graduation mark. Just a single calibration. It does not have different calibration. Common sizes are 10 mil, 25 mil, and 50 mil. and it is designed to deliver one specific value with high accuracy. It is used with a pipette filler for safety. You don't use your mouth to deliver it to pipette. But most of us we use our mouth to pipette until we go drink acid. The reason why we don't use our mouth to pipette is so that we don't drink toxic substances, and those things may be poisonous, and so on and so forth. But Nigeria here, we use our mouth, they use everything. We're supposed to use what we call a pipette filler for safety. Now, never pipette by mouth. Use a pipette filler or rubber bulb. Let the liquid drain by gravity and touch the tip to the side of the flask to remove the last drop. Is that okay? That is that for pipette. Then the volumetric flask. Volumetric flask is what is used to prepare solution of precise known concentration. Volumetric flask also has just one calibration. Something like this. This is how a volumetric flask looks like. It has just one calibration. All right, with a flat bottom like something like this. If this one is 250 ml volumetric flask, that 250 ml is 250 ml. You cannot measure 100 ml from this one. Are you getting it? Now, a volumetric flask is what is used to prepare standard solution. So, which is used to prepare standard solution, my dear student? A volumetric flask is what is used to prepare standard solution, which is solution of known concentration, or it is also used for diluting analyte. A flat bottom glass flask with a long neck and a single graduation line. That's what I'm trying to tell you, that it has just a single calibration. It has a precise volume when filled to the line. It is used for containing a specific volume, not for delivery. It is essential for standardization. For containing. What we are trying to say, we are not using the volumetric flask to like transfer. You are used to store, to contain, to prepare and keep. Is that okay? That is what volumetric flask is all about. Then we have the conical flask or the Elimeyer flask. Of course, as name implies, conical flask, something like this. It looks like a cone. The conical flask. To hold the analyte during the titration, the conical flask now they carry the analyte during the titration. Now, the conical shape is perfect for titration because it prevents splashing and allows for easy whiling. Like you are holding it and then doing it like the shaking it so that the something will not splash off. That's why you need the conical flask. Are you getting it now? The narrow neck also helps contain any potential effervescence like lusting it to air. Now, the beaker for rough measurement, storage, and mixing of solution. You know what beaker are used now before they are transferred to precise glassware. So beaker is not a precision instrument. Beaker is not a precision instrument because beaker, you cannot really measure that. Measuring cylinder is not a precision instrument. Measuring cylinder, the ones that are precision instrument are the ones that usually have just one calibration, or you can accurately measure an amount of it, like your burette, your pipettes, your volumetric flask. Those ones, they are precision instruments. And beakers, they are not used for titration themselves. They are just present there in the lab for mixing, for doing any other thing. And of course, you know how a beaker looks like. This is how a beaker looks like. All right. Much less precise than volumetric flask or pipette, used for preparing the analyte solution before a precise aliquot is pipetted out. You first of all use this one to prepare the analyte. That is what you are looking for. Then you now take a pipette, which is more precise, to measure a specific volume and transfer to the what? To the conical flask. Is that okay? Now, supporting equipment. What are some of the supporting equipment you use? Burette clamp, of course, which is also called the Redox stand, to hold the burette securely and vertically during titration. All these ones like this that holds the burette. That's what we call burette clamp. All right, burette clamp. Is that okay? Now, white tile. Why do you put white tile or white paper during titration? It's so that you can visualize your colors very well. You know, some of these tables might have different colors. If you put a white tile, it helps you visualize the color. All right. Then the tripod stand. Tripod stand, please take note of this particular one. Tripod stand. Tripod stand is primary and most essential use of tripod stand is to provide a stable and elevated platform for supporting apparatus during heating operation. So tripod stands is mostly used during heating. Are you getting? During heating. Tripod stand combined with buzzing burner. It's a fundamental piece of supporting equipment used in conjunction with a heat source. Please take note of this. Tripod stand during heating. Now, which piece of glassware is designed to deliver a variable but highly precise volume of liquid? Please, emphasis on variable, like different amounts, but it should be precise. It is not volumetric flask. Volumetric flask gives you only one volume. If you have a 250 ml volumetric flask, this 250 ml will only measure 250 ml. It is not pipette. Pipette has only one. If you have a 10 ml pipette, that 10 ml pipette is 10 ml. It is not beaker. Beaker is not a precision instrument, of course. The correct answer is burette. Because burette, you can close, open, which will help you to deliver variable. That means different amounts. Like you will have different burette reading, and sometimes some of you got 45 mil, some get 30 mil, but you know that that 30 mil is 30 mil. Then you close it back. So the correct answer to this question is what? Correct answer to this question, my dear student, is burette. All right. The primary function of a volumetric pipette is to do what? Accurately transfer one specific volume of liquid, just one specific volume. It's what you use pipette for. All right. Why is conical flask used instead of a beaker for titration? Its shape prevents splashing and allow for easy whiling. Is that okay? Its shape prevents splashing and allow for easy whiling. Is that okay? So that is that. What is the purpose of the white tile placed under titration flask? We say to provide a contrasting background to see the color change clearly. A 25 ml volumetric pipette is used to transfer a sample of acid to the flask. This volume, you said the pipette is what transfers the analyte into the conical flask. So the volume is the volume of analyte being titrated. All right? Exactly. Which piece of equipment is used for preparing a 0.1 molar solution from a solid primary standard like KHP? Is a volumetric flask. Volumetric flask is used to prepare solution of known concentration. Or for dilution, you use volumetric flask. The final initial reading from which piece of equipment are used to calculate moles of titrant reacted? Burette. Final and initial reading of your burette. All right. Now, why must you never pipette by mouth? The solution could be toxic, corrosive, or even what? Infectious. Maybe you are carrying a solution of a microbe, then you pipette it with your mouth. That could be very dangerous. A solution is prepared by dissolving a solid in a beaker and then carefully adding water to the calibration mark of 250 ml. What is the role of the flask? To contain the solution at exact volume for precise concentration, the volumetric flask, that is the role. To contain the solution at an exact volume for precise concentration calculation. I told you that the volumetric flask is used to measure exact volume. The stop cock, like when you whine but something, the analyte drop, you close it back. Stop cock is critical part of which equipment? Burette. When you are doing your burette reading, you say, it don't change, just change. Oh yeah, everybody. Some people will say, whine and now close the thing. You see they drop. Yes, they drop. That is an important part of the burette. Is that okay? So that is basically everything you need to know about glassware. We have others that you can still go through, but these are the basic ones you should know. Thank you very much for your time. We'll see you in the next one.